The Agenda in the Summer with Nam Kiwanuka is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.
More than ever before, algorithms shape our digital interactions, from the Google results we see to what shows up in our social media feeds and way beyond. I'm Nam Kiwanuka. That's all mostly powered by artificial intelligence and what's called deep learning. As we reflect on past conversations, helping us to understand the digital revolution we're living amidst, tonight we'll look back at the power of thinking computers. In 2014, the late Stephen Hawking said, "Success in creating artificial intelligence will be the biggest event in human history. Unfortunately, it might also be the last." In 2018, Elon Musk said, "I think the danger of AI is much greater than the danger of nuclear warheads." And in that same year, an Environics poll showed that 77% of Canadians were concerned that AI is advancing too quickly to properly understand its potential risks. Back in 2015, we heard how widespread algorithms powered by AI already were. Here is our first conversation tonight. Then, as he's been called the godfather of deep learning, Geoffrey Hinton explained where AI was in 2016 and where it was headed.
In my opinion, algorithms and big data are such widespread phenomena that in some cases they help us make decisions very effectively, in probably more effective ways than we could before, right? And then in other ways, because they've become so pervasive and complex and opaque so that it's hard to know what they're doing and it's hard to make them accountable or know if they're resulting in fair outcomes, they can be pretty difficult to regulate. And because of their pervasiveness, their application to insurance contexts, to credit decisions, to employment contexts, I think we have some very big challenges ahead when we try and decide how we want to regulate them.
Well, let me just follow on that, because you said to make them accountable. Who is the them that we are trying to make accountable here so they don't take over our lives in a bad way?
Yeah, that's the tough question, right? I mean, to some extent, algorithms just implement policy. So in some ways, we could say they're just a tool for, making a decision. We've always used tools to make decisions. But because they can, literally use millions of data points, sometimes billions of data points to make decisions, it's very hard to know sort of where accountability should lie. Is it with the designer of the algorithm, or with the institution or policy body that's decided to use it? It's very hard to sort of attribute, I don't want to use the word blame, but to attribute responsibility for responsible use of algorithms.
Jonathan, can you pick up on that? Who are we trying to hold accountable to make sure these things are not a nefarious influence in our lives?
I should make clear that I am very concerned about the rise of big data and how big data products are becoming more mainstream. I was at a university in Toronto. I won't give all of my personal information away on television, giving a talk the other day about how common it is now for universities to outsource their email to Microsoft. This particular university decided that they were going to outsource the student email to Microsoft. And of course, the students, when we talked about this, were concerned, but they weren't really sure why to be concerned. I mentioned a study that came out last year from Carnegie Mellon University that describes how employers are increasingly using big data products to circumvent the law when conducting interviews.
How so?
So for example, if you want to find out someone's sexual orientation, someone's religious background, someone's political leanings, things that typically you don't ask in an interview.
Don't ask? Really aren't allowed to ask, actually.
Right, by law in some places, in most places I'd imagine you're not allowed to ask. But if you're an employer who wants to know those things, this study at Carnegie Mellon demonstrates that that is increasingly something that employers and anybody interested in the big data industry potentially could do. So then I asked the students, do you speak about your sexual orientation in your personal private email? And does it concern you that perhaps the fact that the universities are outsourcing that email to Microsoft, an American company, that perhaps 5-10 years down the road, if sexual orientation, something you mentioned in private in your email, is eventually used in a big data product that employer is using, could that affect you? Something that people wouldn't even think about, a connection that people wouldn't even make because they think their email is private. So that's a big concern.
So Karen, just so I understand this, as long as I never send an email, don't go on Facebook, never send a tweet, stay off Instagram, pay cash for everything, never have a credit card, I'm safe. Is that what you're saying?
Well, no. So actually, that's a great point. So my colleague, Janet Vertesi, did an experiment a couple years ago or last year where she was pregnant and she wanted to see how long it took, she wanted to keep it from the internet, right? She wanted to see how long it took before data brokers figured out that she was pregnant. So there was a really kind of well publicized example a few years ago where Target stores started doing a lot of direct marketing to women that it assumed were pregnant based on things that they would buy, like unscented lotion, right? So we knew that, and pregnancy is a really salient thing for marketers to know about because pregnant women buy a lot of things. So my colleague wanted to sort of see, well, how do I avoid being detected? And the answer was it was basically impossible because even when she did all the things you talked about, she used Tor, like a protected network, she used cash to pay for things, even those activities of trying to opt out generated suspicion. So, she would go pay cash for purchases and she would be told, this makes you look suspicious, like you're gonna get flagged for this, like this purchase is, we feel like you're trying to opt out, and that itself creates suspicion. And as hard as it is for us to sort of opt out of data collection technologies, it's that much more difficult for people who are marginalized socioeconomically. So if you live in a community that's heavily surveilled, or you go to a school that's heavily policed, there is no chance to opt out, right? Just living entails a lot of data collection about you.
So William, it sounds like we should just not bother trying to rage against the machine, this is the world in which we live. Is that right?
To some extent, that's true. A lot of people like to think about data collection in terms of it's something that's brand new that started happening. 130, 140 years ago, people were counting train cars to see how much goods were being shipped. You could literally post someone outside of a retail organization to see how many people were buying things and roughly how much they were buying. It's not that we couldn't collect this data in the past, it's that it was prohibitively expensive to do so because you had to send human agents to actually do the work for you. Now that people are conducting their transactions online, the cost of tracking that data has fallen dramatically, and that's what's opened up all of these technologies for the most part. It's not that we couldn't do it before, it's that we lacked some of the processing power, but the data was also prohibitively expensive to get.
Do you, in your personal daily life, try to avoid the algorithms as much as you can?
Can't do so.
You can't?
No.
So don't bother.
Not going to try.
Not going to try. Here's from the Financial Times. Let me read this excerpt. This is from about a month or so ago. While U.S. law forbids the discrimination of borrowers based on factors such as gender or race, parsing publicly available information on social networks such as Facebook and Twitter has been shown capable of accurately predicting everything from users' political inclination to ethnicity and sexual orientation. Chief among critics' concerns is the ability to use new types of data and computerized algorithms to build proxies that do not overly discriminate on the basis of factors such as race or gender, but may use correlated information to build an in-depth profile of a particular customer. How concerned are you about that?
I mean, it's obviously a source of great concern, but I think what's important to remember is what Marina alluded to, that algorithms don't do anything on their own, right? Algorithms reflect the social and institutional truths of the world in which we live. So, if there is racism, algorithms will pick up, where racism has been present in society, or if there is bias, it'll pick that up. So for example, if say an employer is trying to figure out who to hire, right? And men have always been more successful in a certain career field than women because of all kinds of sources of bias, then the algorithm is likely to just reflect that, right? It'll just say, well, you should hire these men because they've been more successful, right? So there are lots of ways in which algorithms can both mask bias and also reflect the bias that we live with every day.
Do you think people are making enough effort, Marina, to change the coding or the inputting into algorithms so that the discrimination that we've just heard about is less present?
I don't think so.
No, we're not, eh?
My opinion is that this issue might not be yet addressed by community in artificial intelligence. And these are, again, two sides of this story. Okay, one thing is that people who design and implement algorithms. It's another side of the story, people who provide data and who want to use the results of this. So I think this point has to be addressed in both communities.
Do these two factions talk to each other?
Well, I would say it needs more work on talking to each other.
Even if they know that all of this is happening, it doesn't sound like there's really much we can do about it, is there?
I'm not sure there's much that the individual can really do other than attempting to trick algorithms, like was alluded to, by sort of moving to cash transactions. But even that will flag you anyways. The real issue is that it's really, really cheap to have a lot of eyes on a lot of people right now. And with 1 billion eyes staring at us, they can collect all kinds of data. And you're probably not going to be able to hide from every form of data collection, no matter how vigilant you want to be, barring moving to a shack in the Yukon.
I often ask my students, is privacy dead? And the students are like,
What's privacy?
maybe, right? And then I say, it's up to you. Privacy is a civil liberty. And if we want it in this country, we have to fight for it. Sure, top-down initiatives are a good idea, as I've already mentioned, but I think bottom-up ones are a good idea too. So this requires people to get involved, to push their ISPs to be more transparent about where they're routing data, about who they're sharing it with, to be like Max Schrems from Germany, who requested his 1,200 pages of data from Facebook to get a sense of what they're keeping and what they're not keeping. They're keeping everything. Yeah. And this sort of thing. And this will push the government to create stronger laws, to create enforcement mechanisms to hold these companies to account. Because at the moment, in my opinion, the government is barely involved.
Karen, in our last half minute here, let me give it to you. What's your view on this?
I mean, clearly there's a role for bottom-up and top-down movement here. There's a role for industry, there's a role for the consumer, and then there's a role for regulatory bodies. I think in the end, you could understand big data as being sort of the next side of civil rights struggle, in that, its outcomes can have, very severe effects for people who have been subject to discrimination in the past. And just as with those struggles, I think it needs to be sort of a multi-pronged, multifaceted approach to solving some of these issues.
Google knows what you want to search before you finish typing. Facebook can tag you automatically in a photograph. Heck, cars can drive themselves now. That's not just computers getting better, that's artificial intelligence getting smarter. Geoffrey Hinton's 3 decades of work on deep machine learning helped make it happen, and he joins us now on where AI is today and where it's headed. He's a professor of computer science at the University of Toronto and a distinguished researcher at Google, and it's great to have you here at TVO.
It's great to be here.
Want to just give us a basic definition of deep learning to start with?
So your brain has more than 10 billion neurons in it.
Even mine?
Even yours.
Okay.
And the way it works is at each moment, each neuron has to decide whether to go ping. And it bases that decision on pings it gets from other neurons. And it weights those pings. So some pings it takes a lot of notice of. And these pings tell it either you should go ping or you shouldn't go ping. And it changes those weights. So by changing how much it listens to other neurons, a neuron can change how it behaves. And that's how you learn everything. So that just leaves one question, which is, what's the principle for changing how much you listen to other neurons? And that's called a learning algorithm. And deep learning is a learning algorithm for changing how much one neuron will rely on other neurons to decide whether to go ping.
Do I assume there's a shallow learning as well?
Oh yes, there's shallow learning. That's what the other people do. And okay. That doesn't have lots of layers of neurons between the input and output.
So we're into deep learning here. How does deep learning mimic how humans learn about the world?
Well, nobody really knows how in the real brain you change the strength of the connections that determine how much one neuron affects another neuron. But in the 1980s, people came up with a very effective algorithm for doing that. And it's meant to be a simplified model of the brain. Nobody knows if the brain actually works like this. And back in the 80s, people were very suspicious because the algorithm didn't work that well. But as computers got faster and we got bigger data sets, this algorithm now works really well. It's used all over the place. It's used in your cell phone. And so now it seems like a better bet for what the brain might be up to.
You know who made it up, this algorithm?
It was invented first in about 1970 by some obscure guy. It was reinvented by lots of people. And then in the 80s, when computers were fast enough to implement it effectively, people started using it and showing what it could do. But computers weren't fast enough to make it really impressive then. So mainstream AI didn't believe in this algorithm. What happened a few years ago was computers became fast enough, and suddenly this algorithm started solving all the problems that mainstream AI couldn't solve, like recognizing speech, for example.
Would Watson, the computer from Jeopardy, who beat everybody, would that be part of what we're talking about here?
There's little bits of machine learning in Watson, and some of those bits may well use this algorithm, but mostly it's hand programming. It's a very impressive system, but it involves a huge amount of human labor to make it work. And the idea of these artificial neural networks is you'll try and learn everything.
I suspect everybody knows who Watson is, but on the chance you don't, let's show a clip and remind everybody. Here's Watson from Jeopardy, who was awfully good. Roll the clip, please.
Final frontiers for 1,000, Alex.
Tickets aren't needed for this event, a black hole's boundary from which matter cannot escape. Watson.
What is Event Horizon?
Yes.
Literary character, APB, for 200.
Wanted for a 12-year crime spree of eating King Hrothgar's warriors. Officer Beowulf has been assigned the case. Watson.
Who is Grendel?
Yes.
Final frontiers for 200.
It's Michelangelo's fresco on the wall of the Sistine Chapel, depicting the saved and the damned. Watson.
What is The Last Judgment?
Correct.
You know, it's amazing either of the other two guys got anything right, but I did notice they had something there. Okay, again, let's go through this. How does the artificial intelligence in Watson compare to deep learning?
So the main difference is in deep learning, you're trying to learn everything with nobody programming it. The only thing that gets programmed in your computer simulation is the learning algorithm. So everything inside this neural net gets learned from data, not programmed in by hand.
So they're thinking.
Yes, you could say that.
I just did.
Yes.
Is that accurate, though? It's independent thought in some respects?
You might irritate some philosophers, but yes, I think they are thinking.
That's very heavy. All right, let's, we got an example of this here. Shall we try this? Got my trusty device here.
Okay.
This is a Google Translate program for the iPad, which apparently can translate Spanish to English. That's what it's programmed for right now. Sheldon, you want to get the camera on this and we'll try this? We've got here something that says hola, Spanish for hello. Now let's see if this is it. It's programmed into here. We're going to put this on top of, oh, and there it's happening already. Look at that. You put the camera above hola, and it instantly translates over and over again to hello. Can you walk us through how the neural networks are, first of all, what's a neural network? Because that's what's at play here, right?
Okay, so a neural network is a simulation of a whole bunch of neurons, and it's something that learns by changing the connection strengths between neurons.
And is that what's happening here?
So for recognizing the characters, it uses a neural net. And that neural net is trained on lots and lots of characters from lots of different fonts and with lots of different distortions and noise. And a neural net is currently the best system for being able to reliably recognize characters that are deformed and noisy.
Now, did this program just translate that because somebody made a code to consider every possible word in Spanish to translate? Or is this thing thinking?
Okay, for this particular program, I think currently it's not using neural nets to do the translation. It's using neural nets to do the character recognition.
Oh, okay.
But Google and other people already have neural nets doing translation, and they're doing translation. They're not being used online at present. When you do Google Translate, it'll look at phrases in one language and translate them to phrases in the other language, and it has this huge table. But there's a new way of doing machine translation that's much more interesting that uses neural nets, where it reads the sentence in one language and turns it into a thought. That is, when I say something, that expresses a thought. And obviously the way to do translation is to figure out the thought being expressed in the first language and say the same thing in the second language. And Google now has translation systems that work like that. They're about comparable with the existing translation system on a medium-sized training set. They're not quite as good as the existing system on a really big data set yet, but they will be. And in a few years' time, we'll be doing machine translation by take the sentence in one language, turn it into a big pattern of neural activity that is the thought behind that sentence, and then say that thought in the other language.
Can it understand nuance when it sees it?
It understands some nuance. At present, it can use a lot of improvement still. So there's some things it can't do at present. Like if I say to you in English, the trophy would not fit in the suitcase because it was too big, you know the it refers to the trophy because it wouldn't fit.
Yes.
But if I say the trophy would not fit in the suitcase because it was too small, you know the it refers to the suitcase. And that's real world knowledge affecting how you translate. Now, if you translate from English to French, in French you just can't say it. You have to choose a gender.
Yes.
And so we can't translate that English sentence into the correct French sentence yet, because you need real world knowledge to decide what gender to make that it. That will happen. I don't know if it'll happen in a few years or 10 years, but once that happens, we'll know that it's really understanding.
And it can figure out homonyms without any difficulty?
Stuff like that's no problem.
That's easy
It's the
stuff.
use of complicated real world knowledge to disambiguate things. And it's beginning to be able to do it, but it can't do it properly yet.
Is there one area in particular that you think deep learning is going to change the future?
No, I think it's going to change the future in lots and lots of areas. So let me give you a few examples.
Yeah.
Over the last few years, it's sort of become the method of choice for recognizing speech. It's now becoming the method of choice for transcribing speech. So going all the way from the sound wave to a transcription of what's said with just one neural network that does everything. It's going to become the method of choice for machine translation. Suppose you want to design a new drug. You'd like to know, I'd give you a bunch of candidate molecules, and you'd like to know how well they'll bind to some target site. And you'd like to predict that rather than doing the experiment, because it's much cheaper to do a prediction than an experiment. And then you only experiment on the ones that are predicted to work well. And neural nets recently became the best method of doing that. If you want to identify a pedestrian in the road, a neural net's definitely the best method of doing that. So it's all over. These neural nets, especially the ones using these deep learning algorithms, are going to be used everywhere.
How many years away do you think we are from a neural network being able to do anything that a brain can do?
I don't know. It's very hard to predict the future beyond 5 years. I don't think it'll happen in the next 5 years. Beyond that, it's all a kind of fog, so I'd be very cautious about making a prediction.
Is there anything about this that makes you nervous?
In the very long run, yes. I mean, obviously, having other super intelligent beings who are more intelligent than us is something to be nervous about. It's not going to happen for a long time, but it is something to be nervous about in the long run.
What aspect of it makes you nervous?
Well, will they be nice to us?
It's just like the movies. You're worried about that scenario in the movies.
In the very long term, yes.
Where they
I think
turn
over the
on
next
us.
5 or 10 years, we don't have to worry about it. Also, the movies always portray it as an individual intelligence. I think it may be that it goes in a different direction where we sort of develop jointly with these things. So the things aren't fully autonomous, they're developed to help us. They're like personal assistants. And we'll develop with them. And it'll be more of a symbiosis than a rivalry. But we don't know.
Is that an expectation or a hope?
That's a hope.
That sounds like more a hope
Yeah.
than an expectation. Let me read this here. This is from a piece in the Daily Beast last December by G. Clay Whitaker, talking about the year AI took the wheel. Artificial intelligence did more than look at algorithms this year. And while we've heard about supercomputers and quantum computing for years, this is the first time that any of that lightning fast, thinking out an answer tech started sharing the roads, the roofs, and the responsibilities with you and me. And people are split over whether that was a good thing. I do want to pursue this, this notion of expectation versus hope. You hope it'll all work out well. But in the long run, I sense your expectation may not be quite as benign. Is that fair to say?
I think it's very, very hard to know what will happen beyond a 5-year horizon. So my state of mind is I just don't know what's going to happen. I think trying to stop the technology would be very hard. I mean, if you look at automatic teller machines, My guess is back when they were introduced, people complained about them putting bank tellers out of work. But I think nobody now would say they were a bad idea.
Even bank tellers?
Even bank tellers. I mean, their jobs are more interesting because they deal with the tricky cases rather than you just wanted to take $20 out.
Right.
So it's clear that that technology is a force for good. Whether a technology is a force for good or for bad depends a lot on the political system and what the political system decides to do with it.
That's what I wanted to follow up on, because clearly things in so many different areas of life are changing so quickly, faster than our political systems are designed to make rules and laws around them. So how deeply involved do you think politics has to be, or governments have to be, in order to deal with the changes that are coming in this sector?
They're going to have to be involved. So if you just take driverless cars, it's pretty clear to everybody in the industry, I think, that driverless cars will save a whole lot of lives, but the politicians are terrified of the first time a driverless car runs somebody down. So politically, if a driverless cars kill a few people, but save tens of thousands of people, that's a problem for the politicians. But they should just face up to it and say, look, these things are going to make us much safer.
It'll take a brave politician to say, I know 2 people were killed, but here's the 10,000 we saved. You can't see the 10,000 saved, you can certainly see the 2 killed.
Yes.
So
and there's going to be a lot of that, but it's very clear that driverless cars are going to be a good thing.
Okay, so in conclusion, what kind of impact do you hope deep learning has on our future?
I hope that it, for example, allows Google to read documents and understand what they say, and so return much better search results to you. So you can search by the content of the document rather than by the words in the document. I hope it'll make for intelligent personal assistants who can answer questions in a sensible way and have a sensible conversation as opposed to a conversation that keeps getting derailed. It'll give us driverless cars. That's clearly going to come fairly soon. It'll make computers much easier to use, I think, because you'll be able to just say to your computer, how do I print this damn thing? And the computer will do it, rather than you having to figure out all these commands.
So it should make, if you're right, it should make our lives better.
Yes, it should be just like automatic teller machines, that we should make that little bit of life better, but it should do that for a lot of things.
Fingers crossed.
Yes.
Geoffrey Hinton, it's good of you to join us at TVO tonight. Thanks so much.
Thank you.
And that's it for tonight's agenda in the summer. Tomorrow, a conversation with renowned journalist Ted Koppel and his book, Sounding the Alarm About Cyber Threats to Critical Infrastructure. I'm Nam Kiwanuka. Thanks for watching TVO and for joining us online at tvo.org. And we'll see you again tomorrow.
The Agenda in the Summer with Nam Kiwanuka is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.
The Agenda in the Summer with Nam Kiwanuka is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.